Okay, so in this lesson, we're looking at collision theory, which helps us to explain why some reactions happen more easily than others. Okay, so by the end of the first video, you should be able to describe the 3 parts of collision theory. You will need to take notes in the form of Cornell notes. Since you probably don't have your notebooks at home, please use the online template or the digital template that Mr. Strickler gave you. Okay. So we had the question, why don't all reactions happen spontaneously? For example, when we had sodium and water, it reacted really vigorously, but when I had sodium in the air, it didn't really react all that much. Okay. We know from our periodic table and from the reactivity that the number of valence electrons affects how quickly substances are going to react. But there are a couple of other pieces that go along with this. Okay, so first let's review the reaction of sodium and water. When sodium is placed in water, a chemical reaction happens. Okay, we know this because we saw signs of chemical change like we had previously listed. There's a release of energy in the form of sound and light, and then the little explosion at the end. The gas was produced, there was some bubbles and steam, and the original substance, being sodium, was used up completely. What we can do is we can actually communicate this like a math equation. So what we do is we write our reactants, which are the original substances that we had, and we put them ahead of an arrow, which indicates that the chemical change happens. Okay, so basically the arrow represents the reaction. So sodium and water react to form the products, which are sodium hydroxide and hydrogen. These are the new substances that are formed. When sodium and water react, they fulfill all of the parts of the collision theory, but when sodium and air were in contact with each other, they didn't necessarily meet all the criteria. So let's look at collision theory to explain this. So the first thing, anytime you see the notebook symbol, you do need to write this down. Okay, the first thing is that we have to have a collision for a chemical reaction to occur. Okay, so the particles, whether they're atoms, ions, or molecules, they have to collide. They have to hit each other for a reaction to happen. Okay, a couple of things affect the collisions. 1, the number of particles that you have, and 2, the space that you have available. Okay, so when we were looking at sodium and water, there were a lot of water particles that were colliding with the sodium. Okay, if we compare that to the sodium in the air, we know that gases are further apart for the particles. And so there was less particles that could collide with the sodium, and therefore less collisions. We are less likely to have a chemical reaction. Okay, so you can make a reaction happen by increasing the amount of the substances you have, or by making the space smaller. Okay, basically, if you bring the particles closer together, you're more likely to have them hit. For example, if you guys are out on the field, you can run around without likely hitting each other. But if I locked you all in the bathroom, you would probably hit each other because there's less space and more of you in that space. Okay? The second thing that happens is that particles have to collide in the right direction, basically, for the reaction to happen. So they have to be lined up just so for the reaction to happen, which is why not all collisions will actually cause a chemical reaction to happen. Okay, so in this case here, A and B hit each other, but they hit each other side on, and no collision happens. Okay, because they're not lined up correctly. However, if we change the orientation, we change the direction that they hit each other, we can have a collision. Okay? So this is just a couple of other examples. You don't need to worry too much about this part right now. It's just so that you know that even when there are collisions, if the particles aren't lined up correctly, you won't have a reaction. Okay? The last thing is that reacting substances must collide with enough energy to form or for the reaction to actually happen. Okay? And this is what we'll talk about